Alright, let's solve the Leetcode problem. So the Leetcode problem is a measurement matrix sum. So we are given a two-dimensional integer array matrix. We can do the following operation in any number of times. So there is no limits on how we can do the operation on each row or each columns. Two elements are considered adjacent if and only if they share a border. Okay, so our goal is to maximize the summarization of the matrix element. Return the maximization of the matrix element using the operation mentioned above. So to understand the problem, how about we go through the XML one by one? So they are provided like two XML. So to understand the first XML, we want to do the any operation, multiply each of them by 1 based on the whether the adjacent or not. So according to that XML ones, we are given like 1 minus 1 minus 1 1. So if we stack vertically, so it's highlighting here like based on this operation, we can select the first row, which is index 0 row, that we multiply by minus 1. So that make the second index of the index 0 row to become the positive integer, and then the index 0 and row 0 to make the negative integer. So which help us to convert that vertically to become the all positive integer, and then that becomes the all ones in here. So by summarization of all of this, that became the to the outputs of 4, and we return it in here. So if we go through the XML 2, we have three negative integers in here. Let's consider like we are having like 1, 2, 3, and then minus 1, minus 2, minus 3. Let's create like this. And then 1, 2, and 3. Why so ugly? Okay, bear with me for the ugliness. Alright, so we have a lot of options to do in here. How about this definitely sure if we convert these two into the positive integer. So let's consider like what are the current value that we have for now. So 1, 2, 3 is in here. 3 plus 3 is 6. 6 in here. And then the same is a 1, 2, 3 is a 6 in here. 6 and 6 is a 12 at the moment. So we can consider like multiple approach. What are we going to do is to have the largest positive integers by multiplying with the minus 1 for adjacency. So we cannot multiply all of the negative rows by multiplying with the minus 1, since we only allowed to do the two elements as adjacents if they share the border. So we have two options. We multiply this 2 with the minus 1, or we multiply this 2 with the minus 1. So by checking the numbers, so we decided to multiply the index 1 and index 2 of the row 1. So by multiplying with the minus 1, that began the positive integer, began 2 and 3. So 2 and 3 is a 5 with the minus 1, that will be the 4. So 12 plus 4 will make us a 16, and that is the answer in here, 16. So to decide that, the best approach to use in here is I'm gonna keep track of the absolute sum, like what are the total sum of the each row, and then minimum absolute. So by calculation, like let's say we have something like minus negative in here. What could be the minimum negative number that could appear in there? Next is of negatives. So that is we want to keep track of how many negative integers we are seeing inside there. So initially I'm gonna put everything as a maybe we just put the minimum average as a max, and then odd negative f as 0. So to iteration through this, I'm gonna iterate through like a for in for the matrix. So we get a row. So for number in row, so we are going through like from 0, 0, 0, 1, 0, 2, things like that for row by row, and then by going through the index like 0 till the end. So the first thing we want to do is we want to check what is the absolute sum of all these numbers. What we can do is by removing the whether the positive or negative, we want to get the absolute, which is the native ABI in Swift. We can just use the absolute function. That if there's a negative, it would convert it to the positive integer, and then we're gonna convert it. But in here, I also want to calculate the minimum absolute. So to calculate the minimum absolute, I want to check like what is the minimum absolute number we could get. So our initial of the minimum absolute is much like the maximum number of integer possible in our operating system. Like if it is a 32 bits, that will be the 4 million because it's a 2 power 32. And then I want to check with the absolute of this num. So we need the minimum across these two numbers. So by comparison of the existing minimum number and then largest minimum numbers, so we're gonna keep track of what are the minimum numbers we could find in there. And then if everything went well, we want to check the number is positive or not. By checking that, we just want to check it is a negative or not. So instead of like checking reversely, we check like if a number is less than 0, that makes sense. It's everything become the negative. And then I'm going to use the XOR operator in here. So to explain about the XOR operator, so let's consider we have 0 and 1. I'm want to choose with the something like this op negative. That should be then negative should be neg. I will use the XOR operator. So we could possibly have 0 and 1 in here. By using the 0 and 1, I'm gonna use the XOR operator with the 1. So by all means that, so let's consider we have 0 and 1 can come to our integers values, and then we have like 1's coming through. So if 0 to the XOR of 1 will become the 1. So this is a binary XOR operator, and then 1 met with the XOR of 1, that will be the 0. So technically, if it is the same value, that is going to return the 0. If it is not the same value, that is going to return the 1. So this is technically checking like how many negative integers that we are seeing in our numbers. So it's something like we're toggling the odd negative numbers. So if everything went well, we can just calculate our final answer here by calculation of so we have absolute sum. So we need to remove the odd negative number by multiplication with the minimum absolute. So what does that mean is we have a minimum absolute that could be the negative or whatever, and then we multiply with the 2 for that. So let's try to run first before I explain why we need to multiply with the 2. So okay, it went well. So the reason like we not just subtracting or like instead of like multiplying with the 2, so we have a distance something like this from 0 and plus 1 and 2. So before we understand this, we need to check about what are the possible end range. So it is in between of the 2 to the 250. No, it's a minus 10 power 5. That is a 10,000, negative 10,000 to the positive 10,000. So to explain the easiest operation, I better write down in here. Let's consider that we have a matrix like -1 and 2 only. And then we got the absolute sum of 3, because by getting the absolute of 1, that is the combination will be 3. And then we have an absolute minimum, which is 1. So these two are explained here. And then we have odd negative. How many odd negative we found in here? 1. So I need to leave it off these odd negative. And then this is for the minimum absolute. And this is for the absolute sum. So which is a 3 variable of double that we declare on the line number 3. And then, so if we detect like absolute sum minus minimum absolute, which we do in here, that will be only 2. So we want to receive the answer of 1 because we have to return the total combination. Let's consider we have only one matrix in here, and then whatever we multiply with the -1, so we want the -1 or -2. Pretty sure we want the -1. By addition of -1 and 2, that would be the answer of 1. Alright, so based on that, if we do the calculation like absolute sum, which is a 3 in here, and then our odd negative, which is a 1, I will explain that in here. So our absolute sum is 3. Let's do the substitution. Our negative of is 1, and then we have minimum absolute of 1. So by according to the mathematical order, we have to do the multiplication first, which makes the -1, and then we multiply with the -3 minus 1, that will be 2, and which we don't want. So that is the reason why we have to multiply with the 2. So that is a simple answer to explain. Hope you guys get it. So by multiplying with the 2, so let's consider that we are multiplying with the 2. So we have to deal with all the multiplication first. So -1 multiplying with everything. 3 minus 2 became the 1, which is the answer in here. Alright, let's try to submit. Yep, I think the time complexity will be of m into n, since we are using the two-dimensional here, and then for the space complexity will be of 1, since we don't have any extra memory in here. Yeah, that's all for it, and then see you in the next video. Bye.